All right, welcome back for part 4 of this series on 3D vectors for IBHL math. Now, in the last 2 video lessons, we observed that it's possible to take any 2 vectors where one of those vectors is multiplied by a scalar, and the sum of those 2 vectors can be made to be put into any direction possible. So this is sort of an extension of that idea, and it's sort of formalizing that into saying that a vector can be the result of the sum of 2 vectors where one of them is scaled to some size. In this case, it's a little bit different of a problem. They're giving you points A and B. Well, not exactly. They're kind of telling you where to find the points A and B. You can find the point A from going along the vector OA, so that would be the point -1, -6, 13. And finding the point B is a little bit harder because we don't know the value of t that'll get B where it needs to go. So, if there's a point AB, clearly there has to be a vector, or rather a line segment AB, and they want the line segment AB to be 3 units long. So, just to understand this, again, since I don't know time, and I don't know exactly where point B is, it's probably not helpful necessarily to get a 3D graph for starters, but at the very least, draw a quick picture so you have, an origin, and then you have points A to B, and so forth. It's the vector OB that's changing as I change time, so the line segment or vector AB is going to be different direction and size depending on the value of t that I find. So that's what these little notations are making, and so I must be able to find a way to express the vector AB, and as we've been observing in the past, we can subtract, this is, I'm sorry, let me start over. Pause the screen and see if you can remember why this is true. This is some of the basic fundamental orientation kind of stuff. But here's vector OB and here's vector OA, and when we subtract them we get the vector AB. So it just kind of cleans up to be a vector with the parameter t included in it. So that is the vector AB. The length of the line segment AB can be found notation-wise using the absolute value marker, and we want the length of that vector to be equal to 3. So it ends up giving us this massive quadratic expression underneath the radical, which can very easily be cleaned up. Then if we square both sides, knowing that vector AB has to be 3, we're going to have 9 equals this quadratic stuff, and all this math breaks down to solving a simple, or, well, an ugly quadratic expression. I did mark this as a calculator problem, but I saw the coefficients were just so friendly that I tried to do this without a calculator, and as you can see, you can get the results without the technology. It's worth a try. Now that I have now that I have 2 values for t, I want to make sure I'm checking it. So I take one of my values for t, -2 of course, I'm not going to choose that ugly one, and I get a vector AB in terms of t, and I verify that its length is in fact 3, and now I'm going to grind out the work with fractions. It turns out it's not going to be that bad. Well, okay, it's bad enough. Going to need some computer action here to get all the numbers crunched, but it does in fact turn out to give us 3. So both of these values for time are going to give us a vector AB that is in fact 3 units long. And the way we can make sense out of this, of course, is we're going to have a vector this way when we have a positive value for t, or I'm sorry, ooh, that didn't work out right the way I thought it would. They're both negative, and they both work, so I think I need to see this in 3D to really understand this better. But suffice it to say, I can have 2 different values of t. I could probably go to, now that I know values of t, I would probably go to GeoGebra if I had the time, and just to see what this looks like and why it's reasonable that there are 2 different values for t, and they're both negative in fact. Anyway, I think that concludes this this 4th installment. In the next installment, we're going to look at the hardest possible problem in this section. It's number 12, and we'll see what we can do with that. So thanks for watching. Stay tuned.